Okay, hi everyone. Welcome to the Yap Education. Today I want to discuss the Cambridge IGCSE Additional Mathematics 0006-11. Paper 1, October, November 2024. Okay, let's look at the question. Okay, question 1. Okay, the diagram shows the graph of the y equals to modulus fx, where the fx is a cubic polynomial. Find the two possible extensions for the x terms, the linear factor with the integer coefficients. Okay, when you do this question, okay, you need to know how to find out the linear factor with the polynomial, cubic polynomials. Okay, let's do it first. Okay, now you can try list out this way. You can take fx equals to, okay, this is a coefficient. Okay, bracket x plus 4y, because you see here, x equals to negative 4. And then here x equals to 1 over 2, x equals to 2. Okay, if you want to write in the factors form, you can write this way, x minus 2 equals to 0. 2x minus 1 equals to 0. X plus 4 equals to 0. So you can take a bracket x plus 4 bracket 2x minus 1 bracket x minus 2. Okay, now we don't know this value, right? So how to find it? Okay, you can using this y-intercept to find it. Okay, so let's see. Okay, here you can put 24 equals to a bracket 4. Why 4? Because x is equal to 0. Okay, bracket negative 1, negative 2. Okay, okay, here you will get a equals to 24. You will get equals to 3. So fx equals to 3x plus 4, 2x minus 1, x minus 2. Okay, but you separate the question. Question says find the two possible expressions for the fx side. Okay, so you have another answer. Fx equals to negative 3x plus 4, 2x minus 1, x minus 2. Why got this answer? Okay, now I sketch for this graph first. Okay. Because you see here is modulus, right? Okay, so actually it's got two possible ways. So you can sketch this way. Okay, okay. And then here is negative 24. Here is negative 4 is 0.5 is 2. And another way is show like this way. It is 24 is negative 4, 0.5, 2, x, y. Okay, actually it's got two possible ways here. Okay, now we already finished question 1. Okay, let's look at the question 2. Okay, question 2. Given that 256 power x plus y multiplied 16 minus 2x equals to 8 negative x plus 3 1. Show that the y equals to 3x. So how? Okay. Now I can copy the question first. Okay, now we try to relate these three values. What is the similar here? Because they are basic is 2. So you can write this way. 2 power 3 negative x plus 3y multiply bracket 2 power 4 negative 2x. Then let's see what. Okay, this part you can change to 2 power 8 x plus 1. Okay, now you can start to apply the uh, law of the x. Okay, so you can apply here 2 8x plus 8y multiply 2 negative 8x equals to 2 negative 3x plus 9y. Okay, you see here is multiply, right? So you can write 8x plus 8y minus 8x equals to 2 negative 3x plus 9y. Okay, for the 8x, okay, we can cancel. So you will get 2 8x, 8y, 2 negative 3x plus 9y. Okay, because you see it's the same base, right? So you can directly use compare. Okay, okay, so you can transfer. So 9y minus 8y equals to 3x. So y equals to 3x. Okay, let's see the question B. Hence, find the exact solution. Okay. When you see this keyword, please don't write the answer in decimal place. Okay, okay, exact solution of the following simultaneous equations. So how? Okay, you don't need to repeat the step again. Okay, for this simultaneous equations, you can directly to use y equals to 3x. Why? Because question already say hence. So you can directly to use these equations. Okay, y equals to 3x. Okay, so for this, I consider as first equation, second equations. For first equation, I will substitute into the second equations. X squared plus 3y, which is 3x squared, right, equals to 556. Okay, x squared plus 3 bracket 9x squared equals to 56. X squared plus 27x squared equals to 56. 28x squared equals to 56. X squared equals to 56 divided by 28, we will get 2, right? Okay, now try to write in the square root, positive, negative, square root 2. Okay, now we have got two values, right? Okay, positive, negative, uh, square root 2. And then now we need to find the y coordinate. Okay, for the y coordinate, because, okay, positive, sure you will get positive 3 square root 2. If you put a negative square root 2, you will get negative 3 square root 2. So you have two answers here. Okay, so I try to summarize the answer. X equals to positive square root. Okay, with y you will get positive 3 square root 2. Okay, and then x equals to negative square root 2. Y you will get negative 3 square root 2. Okay, now we see the question 3. Okay, the diagram shows the part of the graph fx equals to a cos bx plus c, where a, b, and c are constant. Given that fx has the period of the 960 degree, find the values of the a, b, and c. Okay, when you see this part, right? Okay, you need to understand okay, how to find it. Okay, okay. One here is 965. Okay, so okay, this part. Okay, here is total I will get 640, right? Uh, equals. Okay, now we can try to find the A4 versus got C. Okay, now I know it. Okay, so we can take B is 316 degree equals to 960 degree. Okay, 960 degree plus B equals to 360 degree. Okay, so you will get B equals to 3 over 8. Why? Because we know 1 period for cos is 360 degree, right? But the question give you is fx has period of 960 degree. So you need to take 960 degree put into the x. V equals to 360 degree. So you will get 3 over 8. Okay. Okay. Now let's try to find the value of the a first. Okay. So we can take 6 equals to a cos 3 over 8 0 plus plus c. So that 6 equals to okay a plus c. Let's try one. Okay, 0 equals to a cos 3 over 8 320 degree plus c. 0 equals to okay, you get negative 1 over 2a plus c. So we can doing some simultaneous equations here. Okay. Hmm, 0 equals to negative a plus 2c. So actually, I can use the eliminations method. Okay. A plus c equals to 6. Negative a plus 2c equals to 0. Okay. Actually, I also can use the substitution. So, a equals to 2c. This is second first. So I take the second, sub into the first. 2c plus c equals to 6. 3c equals to 6. C equals to 2. And then a equals to 2 bracket 2, we will get a equals to 4. Okay, let's look at the next question. Question 4. Given that integral 2a plus 1, 0, 8 over 4x plus 3dx equals to ln 16, find the exact value of the constant a. So how? Okay, when you do this question, okay, please memorize. Okay, a means okay, here you have the equations right. A dx will equals to ln ax plus c. Okay, I hope you can understand. Okay, I hope you understand. Okay, so now we try. Okay, you see, 4x plus 3, right? After differentiate, okay, 4x plus 3, after differentiate, you will get 4, right? But you see what is the value here? 8, right? So you need to separate out the value first. So you can integrate 2a plus 1, 0. Okay, you can take out 2 bracket 4 over 4x plus 3 dx equals to ln 60. Okay, so you can take out the 2 first. 2 ln. Okay, bracket, uh, put the big bracket first. Ln, okay, 4x plus 3, 2a plus 1, 0 equals to ln 16. Okay, or ln 16 also can be 2, okay, bracket 4, 2a plus 1 plus 3 minus, okay, here's 3 equals to 6, ln 60. Okay, now we try to find out the value first. Okay, so 2 ln bracket 8a plus 4 plus 3, right? So actually it's 7 minus 2 ln 3 equals to ln 16. Okay, 2 ln 8a plus 7 equals to ln 16 plus 2 ln 3. Okay, or a1. Okay, oh, so I can write out, okay, I can use the alternative way. Okay, 2 brackets, not brackets, okay, ln 8a plus 7 over 3. Okay, why this way? Because we apply this law. Okay, law of the logarithm. So x minus ln y, right? You will get ln x over y. Okay, so we apply this formula. Okay, so I put here ln x is 2. Oh, so here I can write out ln 16 actually equals to ln 4 squared. Okay, so I can take out 2 ln 4. So 2 ln 4. So I can cancel for the 2. Okay, so I can take 8a plus 7 over 3 equals to ln equals to 4. Okay, 8a plus 7 equals to 12. 8a equals to 5. A will equals to 5 over 8. Okay, let's look at the question 5b. In expansion of the 1 plus kx power 15, where the k is a constant, the coefficient of the x cube is negative 29,120. Find the value of the k. Okay, when you do this question, right? Okay, please memorize the formulas of, yeah. So how? Uh, you can see they put our NCR. Okay, we are to NCR D power N Q N minus R. Okay, so please memorize this formula. Yeah, so let's try. Okay, x cubed plus kx power 50. So I can put here in it. So okay, coefficients of x cubed equals to, okay, 50 C3. Okay, C3, okay, kx is power 3. And then another is 1, right? So 1 sharp. Okay, 50 C3, 455 k cube x cube equals to 50 29,120 x cube. Okay, so you can compare. And so take 455 x cube equals to negative 29,150. Negative, you will get negative 64, right? So k you will get negative 4. Okay, so let's see the question B. Find the terms independent of the y in the expansions of ax squared minus 1 over 2y bracket power 12. Okay, when I say this keyword, right, the term independent of the y, it means y power 0 equals to 1. So how? Okay, how you need to find it? Okay, we also apply this same formula here again. Okay, because we need to know 0. Okay, so I put 8y squared. Oh, I write wrong here. Actually, it's not n. Sorry, okay, so I write wrong here. Mm, okay, I write r and then another one square r. Okay, 1 over y. Okay, it means y e. Okay, so 12 minus r equals to y power 0. So you can write here y to r multiply y negative 12 plus r equals to y 0. Okay. So y negative 12 plus 3r equals to y 0. Okay. So 3r minus 12 equals to 0. 3r equals to 12, r equals to 4. Okay, so we can resume back for this r equals to 4 to find out the terms independent of the y. Okay, let's start. So I can take here, okay, 12 c4. Okay, 8y squared 4 brackets negative 1 over 2y 8. Okay, so now I can start to multiply. 12 c4 multiply 8 power 4 multiply negative 1 over 2 power 8. So you will get the answer is 7,950. Okay, y power 8 multiply another is 1 over y power 8. So you can cancel. So you will get the answer is 719, 910. Okay. Okay, let's look at the question 6. Okay, the polynomial p is such that px equals to ax cubed plus 11x squared plus bx plus c, where a, b, and c are integers. So when you see this information, right, this get it. Okay, if you find out the values a, b, and c are not integer, it means you're doing wrong step. Okay, in your step out. Yeah. Okay, let's see. E is the given there. P, okay, see here is comma, right? It means this is the first derivative. Okay, 0 equals to 12. It's also given that x plus 3 is a factor of the p. When p is divided by x minus 1, the remainder is 16. Okay, find the value a, b, and c. Okay. So for this part, you need to know this is a first derivative. Okay, and then for this part is you need to use factor theorem. Okay, for this part, you need to using the remainder theorem. Okay, let's start now. Okay, P, okay, now we're doing the first differentiation. You will get 3ax squared plus 3 okay, plus 22x plus b. Okay, so you can write here 3a 0 squared plus 22 is 0, right? Plus b equals to 12. So we will get the answer is short. Okay, I need very fast. Okay, now we try to find out the values for A and C. Okay, okay. Because you see the second question is a factor theorem, right? So you can take P negative 3 equals to 0. Okay, so A negative 3 cubed plus 11 negative 3 squared plus 12 negative 3 plus c equals to 0. Yeah. Okay, so here we get negative 27 8 plus 99 minus 36 plus c equals to 0. Okay, let's try to simplify it. Okay, c minus 27 8. 99 minus 36, you will get 63 equals to 0. Okay, so let's try. Okay, c equals to 27a minus 63. Okay, so we try right here. This one. Okay, let's look at the third sentence. Okay, third sentence is reminder theorems, right? So how we do? Okay, so you can write here P1 equals to 16. Okay, so you can write here A plus 11 plus 12 plus C equals to 16. Okay, so you can take A plus C plus 23 equals to 60. Okay. So A plus C equals to 16 minus 53, you will get negative 7. Okay, so I consider this a first equation, second equations. So first equation will substitute into the second equations. A plus 27a minus 63 equals to negative 7. 28a equals to 63 minus 7 equals to 56. So A will equals to 56 divided 28. You will get A equals to 2. Okay, so now we try to find out the values of the C. The C equals to 27. A is 2 minus 63 equals to 23 and 27. 27 multiplied by 2 minus a 63. You will get negative 9. Okay, so I can summarize answer here. A equals to 2. B will equals to 12. Okay, C will equals to negative 9. Okay, so this is the answers for the question 6. Okay, let's look at the question 7. When e power 5y is plotted against x cubed, a straight line passing out the points negative 2.56, 4.38, and 6.54, 9.84 is orbited. Find the y in terms of the x. Okay, this is a linear line equations. This is your x-axis, right? X-axis cube. This is your y-axis. E by 1. Okay, you have points here. Wait a minute. Okay, we have points here. Okay, negative 2.56, 4.38. And then you have another point here, 6.54, 9.84. This is your straight lines, right? Okay, so now we need to find we need to find the gradients. We need to find these equations. Y minus y1 equals to m x minus x1. Okay, now we need to find the gradient first. Okay, this is very important information. So m equals to 9.84 minus 4.38 over 6.54 minus 2.56. Okay, so you will get, so you will get 3 over 5 or 0.6 here. Okay, so I can take, okay, you can choose any points from here. So I will choose for the positive. So I take y minus 9.84 equals to 0.6 x minus 6.54. So y will equals to 0.6 x minus 6.54 multiplied 0.6. Okay, 3.924 plus 9.84. So y will equals to 0.6x plus 9.84 minus 3.924. So, okay, 5.916. Okay. Now we need to substitute e 5y equals to 0.6x cubed plus 5.916. But the questions already says y in terms of the x, right? So you can try right out. Find y equals to lots 0.6 x cubed plus 5.916. Yeah. Okay, so you can write the answer. Y equals to ln 0.6 x cubed plus forget to write 1 over 5 ln 0.6 x cubed plus 5.916. But this is not the final answer. Why? Because we need to write the answer in three significant figures. Okay, especially for this part. Okay, so I write y equals to 1 over 5 ln 0.6 x cubed plus 5.92. Okay, this is your final answer here. Okay, and then we try to look at the question B. Find the value of the x which y can assist. Okay, now you can try to look at this is a logarithm, right? Okay, for we know logarithm. Okay, I write here y equals to log x, right? Okay, The x cannot goes to 0. It should x more than 0, right? We're using this concept to apply for these questions. Okay, so we can take here 0.6 x cubed plus 5.916 more than 0. Okay, so you can write here 0.6 x cubed more than negative 5.916 x cubed. Why I take back for this part? Because I don't want to faster to round off the answer. So I will using back for the 5.916. But okay, so okay, negative and need. Okay, so I will get negative 9.86. Okay, so because here is x cubed, right? So you can directly to use, you will get negative 2.14. Okay, this is your final answer. It means your x should be more than negative 2.14. So for this function, there will can be axis. Okay, please remember this part. Okay, properties of the logarithms. Okay, let's look at the question 8. Given that, okay, second derivative equals to 3x plus 5 power negative 2 over 3. Okay, first derivative x equals to 1 equals to 6. And when x equals to 1 equals to 25 and expression for the fx. Okay, I hope the student can understand for this question because you see here it's got how many marks here? 8 marks, right? So I think it's not very difficult, but please be careful. Okay, because the student will do the mistake here. Okay, when you see this question, you need to integrate how many times? Yes, 2 times. Because you see here is second derivative. So you need to integrate 2 times. So you can take f integrate x equals to 3x plus 5 negative 2 over 3. Okay, so this is the first derivative equals to integrate 3x plus 5 negative 2 over 3 dx. So you can write here 3x plus 5 negative 2 over 3 over a, sorry, I forget, plus 1. So 1 minus 2 over 3, you get 1 over 3 is, we need to differentiate for the 3x plus 5 here. So you will get 3, okay, plus c. Okay, please don't forget to plus the c here. Okay, so your first derivative is equals to 3x plus 5, 1 over 3 plus c. Okay, so I can have here 6 equals to 3 bracket 1 plus 5 plus c. It is 1 over 3. 8, 1 over 3. 6 equals to 8, 1 over 3 plus c. Okay, 8 actually equals to 2 power of the 3, right? So you can write here 2 power 3, 1 over 3 plus c equals to 6. Answer, okay, 2 plus c equals to 6. C will equals to 4. Okay, how you can get it? Okay, so this is our first derivative equals to 3x plus 5 power 1 over 3 plus 4. Okay, now we try doing one more time integrate again. So you can write here fx equals to integrate 3x plus 5, 1 over 3 plus 4 dx. Equals to 3x plus 5, right? So here you plus 1, you get 4 over 3. 4 over 3, you differentiated 3x plus 5 again. plus 4x plus c. Okay, here I write, okay, 1 over 4 bracket 3x plus 1, 4 over 3 plus 4x plus c. Okay, so I can try to write out first. 20 equals to 1 over 4. Okay, here I'll get 8, 4 over 3 plus 4 plus c. Okay, so 20, okay, so equals to 1 over 4 bracket 2 power 4 plus 4 plus c. 16 divided by 4, you will get 16 divided by 4, you will get 4 plus 4 plus c. So you can cancel. 20 equals to 1 plus 4 plus c. So here you will get 5 plus c equals to 20. Okay, c will equals to, eh, sorry. Actually, here is 16. 16, here is 4. Sorry, I heard it. 4, so here you will get 8. 20 minus 8, you will get 12. Okay, so for your answer, fx will equals to 1 over 4, 3x plus 5, 4 over 3 plus 4x plus 12. Okay, I hope you can understand for this part. Okay, let's go into the next question. Okay, question 9. The equation of the curve is y equals to e negative 3x plus 2 over x plus 1, where the x less than negative 1. Show that the dy dx equals to e negative 3x plus 2 over x plus 1 squared, ax plus b, where a and b are easiest to be found. Okay, so you see these questions, right, called rational functions, right? So how we need to apply what? What's the rule? We need to apply the quotient rules. Okay, remember quotient rules. Okay, we need to apply here. Okay, so you can try out. Okay, y equals to e negative 3x plus 2 over x plus 1. So dy dx equals to, okay, x plus 1 squared. Copy here again. Copy here. Diversity for the denominator. So you will get negative 3. Negative 3 e negative 3x plus 2. Okay, bracket minus okay, you copy back here, e negative 3x plus 2. And then you differentiate for the x plus 1, you will get 1. Okay, you see, look back to the question, we can factorize out what? E negative 3x plus 2 first. Okay, so you will leave the negative x, okay, minus 1, okay, over x plus 1 squared, right? Okay, so right here. Sorry, I forgot one thing here. Actually, it's only to multiply 3. Okay, negative 3x, negative 3, negative 1. Okay, so you'll get the answer is e negative 3x plus 2, negative 3x minus 4 over x plus 1 squared. Okay, I hope you can get it. Let's see the question B. Has shown that there is one only stationary point on the curve and find the exit coordinates. Okay, so how you need to find the one stationary point and determine the point? Okay, now we try to look at here. You see, this is the exponents, right? exponent, right? So what we can know? Yes, that cannot equals to 0 because we know ma, okay, y equals to exponent, right? Okay, your exponent always more than 0, right? They will not happen less than 0, okay? So we can know e negative 3x plus 2 cannot equals to 0, okay, for this part. And then we can try to find out the exact coordinates, right? So, okay, we already know dy dx will not equals to 0. This is first things. And the second is always will more than 0. Okay, so your dy dx always more than 0. And then you can try to look at here, x plus 1 squared. X plus 1 squared. So, also, yes, yes, it's also will more than 1. Okay, okay. So I hope you can get it. Okay, so we can directly to use what? Use this part out. Okay, you see here it's got, okay, never mind, I explain again. Because you see here it's got three terms, right? Okay, one, two, three. Three terms here. Okay, I eraser this part. Okay, one stationary point. Okay, what is the stationary point? Okay, we know stationary point is dy dx will equals to 0. So we need to using these three terms, okay, at least one. Okay, find out the possible will happens the stationary point. Okay, okay, you can try look at e negative 3x plus 2 will not equals to 0. Why? Because we are, if you already learn the logarithms and exponent, we know exponent, the range will always more than 0. So they cannot equal to 0, as we know. And then you see that x plus 1 square, right, also will more than or equals to 0. Okay, for this case, we can say more than 0 because then x plus 1 square puts into the denominator. So should be more than 0. Okay, so just one possible ways can equal to 0, the other is equal to 0. What? You can take negative 3x minus 4 equals to 0. Okay, negative 3x equals to 4, x equals to negative 4 over 3. Okay, so you can write out here y equals to e negative 3 brackets negative 4 over 3 plus 2 over negative 4 over 3 plus 1. Okay, so you can use your calculator to find it first. So y e is cancel positive 4 plus 2 over 1 minus 4 over 3. 1 minus 4 over 3. You will get negative 1 over 3. Okay, now you can do the reciprocal. So you will get negative 3e power 6. So, okay, for your coordinates of stationary point is negative 4 over 3, negative 3e power 6. Please don't write in the decimal place because question is already mentions this keyword. Okay, I hope you can get it. Okay, let's look at the question text. Okay, the third and eighth terms of the geometric potential are 6 and 1488 respectively. Okay, so you can write here U3 equals to 6, U8 equals to 1458. Find the common ratio and the first term of these positions. So you can write here AR squared equals to 6, AR7 equals to 1458. Okay, so A equals to 6 over R squared. A equals to 1458 over R power 7. So you can put together 1 equals to second. So 6 over R squared equals to 1458 over R power 7. So here you will get R power 5, 1458 divided by 6. You will get 243, right? So, okay. So you will get R equals to 3. So now you can find the first term, 6 over 3 squared. 6 over 9. Okay, you will get 2 over 3. Okay, let's look at the question tense. Okay, the first three terms of the second geometric position cos 2 cos squared 4 cos cube, where the theta will happen to be negative 90 until 90. It means, okay, you can try the looks here. Okay, sorry. Okay, 0 is positive 90 degree, negative 90 degree. So your angles will just happen at first and number 4 quadrants. Yeah. Okay. Find the values of the theta which the geometric position has a sum to infinity. Sum to infinity. These are keywords. Okay, now we need to know sum to infinity, right? The modulus R will less than 1. Okay, this is a very important sequence. Okay, so we can try to find out here. 2 cos square theta over cos theta. So you will get 2 cos theta. Okay, so you can put here 2 cos less than 1, right? And then here is negative 1. So we can try to divide it by 2. Okay, divided by 2, so negative 1 over 2 cos 1 over 2. Okay, mm, then, so you can try to use this part. Cos theta equals to 1 over 2. So you can find the reference angle first. Angle first, theta equals to, so you will get 16 degree. Okay, if for negative, okay, we need to get the negative, right? So how you need to get the negative values here? And 16 to be down to get the negative 1 over 2. Okay, cos equals to negative 1 over 2. The theta will equals to negative 16 degree. Okay, so you have the two answers here. Okay, you see there, okay, this cos, right? Okay. Uh, I try to separate out two parts here. Negative 1 over 2, okay, cos. And then the cos less than 1 over 2, right? Okay. Then we try looking at the cos 19 degree will equals to 0, right? So for this part, we can write 16 degree until 19 degrees. And then for this part, because the cos is more than negative 1 over 2, right? So you take negative 19 degrees until negative 16 degrees. So you have two answers here. Okay. Okay, never mind. I try to repeat again. Okay, first, you need doing is find out the common ratio first. Okay, and then you try to use the common ratios, right, to relate the sum to infinity. Okay, we know the sum to infinity is modulus r less than 1, right? So you can write it this way. And then we know the cos they will happen between negative 1 and negative 1 over 2 and positive 1 over 2, right? So we need to separate out first. Okay, the first part is cos less than 1 over 2. And then the another way is negative 1 over 2 cos, right? Okay, now we need to find the cos less than positive 1 over 2, right? So this is your constant graph. Okay, here, here. Okay, this is your 19 degree, right? 0. Okay, this is your 1. So, okay, I try to sketch out. This is your y equals to 1 over 2. Okay, negative 19. Okay, 1 over 2. And then I already find out here is x equal to 16 degree. And then here, x equals to negative 16 degree, right? Now I need to find out the cos will less than positive 1 over 2. It means where? Here, right? This is for positive part. Okay, so they will happen here between. Okay, so you will get this answer. Okay, and then we try to look at the negative. Uh, Checking the answer first. here. Uh, it's part 60. Oh, it is correct. Okay, so you can find out. So you have two answers here. Okay, theta between 16 until 19 degrees, or between negative 19 until negative 16 degrees. Okay, okay, let's look at the question 11 here. Uh, the diagram shows the part of the curve y equals to 4 plus 2 sine 3x and the straight line AB, the points A and B linked on the curve. The x coordinate of the A is pi over 8 and the x coordinate of the B is pi over 3. Find the area of the shattered region, giving your answer in exact box. So how you need to do this question? Okay. Uh, okay, we can try to find out coordinates of the A and B first. Okay. Yeah. Okay. Uh, okay. When x equals to pi over 18, so y will equals to 4 plus 2 sine 3 bracket pi over 18. Okay, x equals to pi over 3. Okay, y equals to 4 plus 2 sine 3 brackets pi over 3. Okay, equals to 5. Okay, 4. Okay, so your coordinate of the A is pi over 18, 5. Your B pi over 3 is 4. Okay, so okay, let's find out using the area of the shutter. Okay, so you can try to integrate pi over 13 until pi over 18. Okay, 4 plus 2 sine 3x dx. Okay, minus, because you see this shape is what? Trapezium, right? So you can use the area of the trapezium to solve this part. Okay, 1 over 2 multiply. Okay, 1 over 3 pi minus 1 over 18 pi. You will get pi over 18 pi. Okay, and then multiply 5 plus 4, you will get 9. Okay, here 4x plus 4. Let's say that 2 brackets negative cos 3x over 3 pi over 3 pi over 15 minus 2 is 1 2. So you will get 1 over 5 over 4 pi here. So the uh, x plus, not plus, minus 2 over 3 cos 3x, pi over 3, pi over 80, minus pi over 4 pi will equals to 4 bracket pi over 3 minus 2 over 3 cos 3 pi over 3, and then minus 4 pi over 18 plus 2 over 3 cos 3 pi over 18 minus 5 over 4 pi. So here you get 4 over 3 pi minus 2 is also. So 2 over 3 cos pi. You will get negative 2 over 3 minus 4 over 15 minus 2 over 9 pi plus 2 over 3 cos 3 multiply 1 over 15 pi. You will get 3 over 3 minus 5 over 4 pi. So it equals to 4 over 3 pi minus 2 over 9 pi minus 5 over 4 pi. Okay, you will get, okay, 3 over 3 minus 2 over 3. Okay, negative 2 over 3 cos, or just positive, positive 2, positive 2 over 3. Okay, and then minus 2 over minus 5 over 4. So you will get 5 over 36 pi. Okay, so this is your final answer here. Okay, okay, let's do the last question. Okay, trigonometry. Okay, so when you see this question, right, okay, you need to know how to apply the trigonometric identities here. Okay, so let's start. Complex. So calculated cosec squared equals to cos squared plus 1. So I can take 2 brackets with cos squared plus 1 minus 5 equals to 5 cos. Okay, so 2 cos squared plus 2 minus 5 equals to 5 cos. 2 cos squared minus 5 cos minus 2 equals to 0. So now I need to do the factorizations. 2 cos is 3 ones. Okay, so minus positive plus. So cos equals to negative 1 over 2, and one more is cos equals to 3. So you will get tangent equals to negative 2, and tangent equals to 1 over 3. Okay, so you can look here. You need to find out the answer between negative 180 degree and positive 180 degree. So how will you to find it? So you need to find for uh for these two parts. 0 until 180 degrees. And then for these directions is 0 until negative 180 degrees. Okay, now we can try to find out the reference angle first. Sixty 3.4. And then we look at the reference again. So we will get 18.4. Okay, let's start. Okay, because this part is negative. If negative, we need to see second quadrant and fourth quadrant. Okay, so equals, okay, negative 63.4, and then one more is 183 minus 63.4. And then we look at another, because this is positive, so we can take it, negative 118 plus 18.4, and then one more is 18.4 degrees equals to negative 63.4 degrees. 118 minus 63.4. So you'll get 116.6 equals to negative 100 plus 18.4. Okay, negative 161.6. Okay, 18.4. So you will get four answer here. So I try to summarize the answer. So first answer is negative 161.6 degree. Second, 63, negative 63.4. Number three is 18.4 degree. And the last is 116.6 degree. Okay. And then we try to look at the last question. Okay. Solve the equation 3 sine 2 theta plus 1.5 equals to 2 for the theta between, okay, 0 and 5. And the theta is in radius. Okay. So how to find? Okay. Multiply. Okay. So we change for this part first. Okay. 2 is 10, 0. Okay. Plus 1.5, 1.5. Theta plus 1.5, 11.5. Okay. So I write out the angles in degree. Okay. This is 85.9 degree. And the one more. It is 658.9 degree. So 3 sine 2 inverse 1.5 equals to 3. Sine 2 inverse plus 1.5 equals to 2 or 3. So we can try to find the reference angle first. Equals to sine 2 over 3. So equals to 4, equals to 0.7730. Okay, so 2 theta plus 1.5. Okay, now we try and look here. Okay, 85.9 degrees. So you need to find this many times of 1 times. Okay, until here. Okay, so try. Point three seven. Okay, this we cannot use because it's less than, it means out of the range. So you need to take out pi minus 0.730 first. Okay, this is the second quadrant. And then we try to look at the first quadrant first again. 2 pi plus 0.730. And then one more part is 3 pi minus 0.730. Okay, pi minus 0.730. So you will get 2.4159. 2 to 7.013 to 8.69. Six, 6947. Okay, so okay, minus 1.870132, 5.5122, 8.69, 4 square minus 1.5, 7.194 plus 7. Okay, now divide the value. Okay, 0.4562, okay, 2.76, okay, 3.60. Okay, so you'll get three answers. Okay, so we already finished. Okay, this paper. So if you forgot, okay, okay, okay. Thank you for watching these videos. Okay, please like and subscribe. Okay, thank you and see you in the next video.